Good morning, everybody. I wanted to talk a little bit about the climatic conditions for the summer heat that was quite notable this last summer across the southern U.S. Really to answer a couple of questions: how unusual, and what were some contributing factors to the heat. I'm a research scientist at University of Colorado Boulder. I work in NOAA's Physical Sciences Laboratory, but I'm going to be showing results from a rapid attribution project from NOAA that has quite a number of collaborators on this, many of them at NCEI that provide a lot of information, climate information from NOAA. I'm going to be talking a little bit about something called the Summertime Warming Hole, just a couple of slides. That's work with Marty Herling, John Eischeid, who have retired from NOAA PSL and Ceres, and Quan Xiaowei at Ceres. So very quickly to go through this rapid attribution project, I want to just give you a very quick background. Our goal is not so much to come in right during the event and say this was climate change, this wasn't climate change. We really want to address some of the more foundational science challenges around warming, including the so-called summertime warming hole. A lot of effort has been placed onto monitoring, hence NCEI's involvement. And we really want to look at multiple causes, not just the climate change issues, and see how they interact. And finally, we're going to talk about something called conditional attribution, which you'll see at the very end is something that I think is essential for understanding this heat event. Now, I'm going to be focusing on heat, but of course, the lack of precipitation was a major factor there. So let's start with a slide that John Nielsen Gavin gave me because it really helps to characterize the event. This is the number of total days above 100 degrees Fahrenheit in this last summer, and in the sort of East Texas, Louisiana, Mississippi area, South Mississippi area. And we can really make some very basic statements. June through August and really through September, I have to move this control panel out of the way. There's a widespread heat wave across the southern tier of the United States. The heat spanned pretty much from Arizona to Florida, but by many measures, the seasonal temperature extremes were centered on the southern portions of Texas and Louisiana and stretching into Mississippi somewhat. The heat persisted, particularly in Texas, into September. And although individual stations set some records, it was really the persistence, just the number of days above these high thresholds. It was just the persistence of the heat, which is really what I would say the defining character of this heat wave for many stations. The heat was associated with near record or record low precipitation. These are rankings shown and for this focus region. As you can see, it was really confined to Louisiana and sort of the East Texas in this graph, but we'll see in a minute. This is the same ranking shown from August through November, so a slightly later period than just the summertime. And as you can see, the drought, the meteorological drought, persisted and to some extent intensified over the eastern part of this area. So let's step back for a second and look at. We talked about days over 100. Well, this is the number of excess days over 100, so above what you would expect in a normal year. And it really does show that the heat did stretch quite widely across the southern, the Gulf Coast and the interior parts of the southwestern U.S. On the left is daily maximum temperature, the number of days over 100 greater than climatology. And on the right is daily minimum temperature greater than 75 degrees Fahrenheit, the number, again, of days above climatology. And in some places it was 60 days more than you would expect. The other thing is you see that this heat wave happens for the most part in daily maximum and daily minimum temperatures. Although I would argue that from looking at these, at the daily minimum temperatures, the nighttime temperatures were centered more towards the east in the more humid, typically humid areas. Now, stepping one step back and looking at a heat wave index for the entire country, we see that, and this shows is the number of 5-day blocks that exceeded the temperature you'd expect to see only once in 5 years. So basically, It's the number of those 5-day blocks, ranging up to maybe nine of them. So that would be 45 days that exceeded what you'd expect in this summer, what you'd expect to see once every 5 years. And you can see that it really does stretch from Florida across to Arizona, a little bit up into the interior west and the northwest, but really the large values, the red dots on this graph, are along the Gulf Coast and southern Texas. On the right is just sort of a cumulative version of this index through the summers, comparing to many different years. And see, from a national perspective, yes, this year's the red curve. It started in June and July, but really from a national perspective, the aerial coverage was not spectacular compared to what happened, for example, in the 1930s, which are the top 4 years among the top 4 of the top five years. So really it was a story of this region being hit hard. You can see that in Texas, if you look at the number of observation stations, and this is the number of those 5-day blocks per observation station on average for the state of Texas, you see that by this measure, 2023, the last point on this graph, was comparable or larger than 2011, the last really widespread severe drought of a comparable magnitude. And again, you'll find out that with heat, what you say about heat may depend somewhat on the metric you use. I'm being rather careful to say that it's particularly by this metric, which is really sensitive to aerial coverage and persistence more than the extremity of any single day. So let's get into some of the factors here. There was a persistent anomalously strong ridge over northern Mexico, north central Mexico, in the upper atmosphere. This is the 500 millibar height. These filled in contours are the anomalous height, and the black lines are the actual total 500 millibar height pattern. But the salient thing is that there was a ridge of high pressure over central Mexico that extended into Texas, to Louisiana somewhat, and to the interior southwest. This high pressure, people often refer to this as like a heat dome because the temperature is not just at the surface. They are commonly associated with heat waves. It is one of the bigger, more common signatures of persistent heat when you do a meteorological analysis. So, mentioned the low precipitation. Again, from a national perspective, you see that this region and the interior southwest were really severe compared to the rest of the country. Many of those areas actually had some of those areas had below average temperatures, and those tended to happen in areas with above average precipitation. But you can see the agreement in the pattern in Texas, Louisiana, New Mexico, and Arizona between temperature and precipitation. We'll come back to that more locally here. Now, since this is really a call that's typically focused on drought, I wanted to look at what the drought conditions were going into the summer. The drought monitor shows some areas of drought in West Texas, not as severe as in some past high temperature years, such as 2011 or even last year. This would indicate that the antecedent soil moisture, the soil moisture coming into the summer, which would tend to favor high daytime temperatures, was perhaps a factor in that region, but not as strong as it's been in others. The really big story with drought is the drought that developed throughout the summer due to primarily to the low precipitation, likely with some feedback from the high temperatures. So that when you have low precipitation, you have the soils dry out. It tends to be clear, but that also tends to exacerbate the actual, particularly the daytime temperatures. So let me make a comment a little bit about what that meant for the forecast models. This is the GFDL SPEAR seasonal forecast model. At various lead times, and the observed in the upper left corner for the 2-meter air temperature. And what you see here is that maybe at 5 months out in the middle panel on the right, you do see a large area, particularly in the western side of this domain, that's forecast or that's predicted to be quite hot. You see that at 3 months out, and you also particularly see that 1 month out. 1 month out, the model is really keying a lot off of the soil moisture that it sees in its initial state. What it did not get is the extension of the drought and the extension of the really severe temperature excursions into the eastern part of Texas and Louisiana and that part of the Gulf Coast. But even 5 months out, it did start to see this area as preferred for heat. And this indicates that ocean conditions, along with the soil moisture in its initial conditions, were perhaps useful predictor and a causative factor in the western side, but that the eastern side was less predictable, and but that doesn't, as we'll see, rule out the role of precipitation. It just says it wasn't seen in advance. There's other model runs that show a similar pattern in the western domain, indicating that the ocean temperatures did play a role, even though El Nino does not have a strong correlation with this region. Now, this is an exercise that GFDL is doing as part of our rapid attribution, somewhat experimental, to try to remove the climate change signal from their forecast, and that's the lower solid red line is what the forecast at various lead months would be for the Texas Louisiana area. The anomaly about the climatology. The reddish purple line above that is the forecast when all the forcings are included, and the dashed line is what occurred. It was in the area they looked at. It was a 1.8 degrees Celsius anomaly, so about 3.6 Fahrenheit anomaly. And you can see that the dashed line was at the upper limit of what you might have expected from the model if you did not have the change in radiative forcing, anthropogenic radiative forcing included. So we'll come back to that question a bit later towards the end. Another factor that was raised with this, and is often raised with Gulf Coast heat waves nowadays, is that there are record temperatures in the Gulf of Mexico. So on the horizontal axis, you see a Gulf of Mexico ocean anomaly, the upper ocean temperature anomaly, which is really average over quite a large area of the Gulf. And on the left, you see the minimum temperature anomaly from climatology over the state of Texas in degrees Celsius here. You see there is a correlation, a fairly robust correlation in the minimum temperature. And you can see with the red dot at the far right, for the year 2023, again, the largest in the period of record that in this data set, and also consistent with perhaps somewhat under a degree of Celsius, so roughly 1.5 degrees Fahrenheit of anomaly. Now, the trends have been removed from these both these data sets. So this would happen even in the absence of trends. So this is just suggesting that whatever caused this excursion from the climatology would also be consistent. But Gulf temperatures really are both cause and effect. It was a heat wave over land. It was also a heat wave over the nearby ocean. So we're still working on the cause and effect. But I did want to mention the winds, because the winds, of course, would bring the warm, moist air off the Gulf into this region. And upper winds are just the average winds this summer, and the lower winds are whether or not they were how they were anomalous from the climatology. And you can see that along the coast, they weren't strongly anomalous. Perhaps in Louisiana, it added a little bit to it, but it's really just the fact that there was warmer and somewhat moister air over the ocean that led to some of the higher dew points and higher minimum temperatures. So very quickly, this is a complex region. I wanted to show this rather complicated graphic, but it shows that the difference between recent decade and a much prior decade for the maximum temperature, minimum temperature, and precipitation. over the U.S. And you can see this is a region we've recently published a paper on what's called the summertime warming hole. There's been many papers published on this. It has lasted much longer than people would have guessed even 5 years ago when papers were written on this. And it shows up primarily in daily maximum temperatures, and you can see that East Texas and Louisiana are really in this area that shows relatively low trends. And in a region that has had a persistent, very high precipitation. As far as it goes, this sort of multi-year wet period in the late 20 teens is really unprecedented in the observational record. Just how that plays out on the ground, this is the Louisiana state temperatures, maximum and minimum. The maximum ones show relatively little or no trend in maximum temperatures, but you do see a trend in minimum temperatures. So keep that in mind, that this region, you'll tend to see long-term trends more in the minimum temperatures than in the maximum temperatures. Now, this is the one graph. If you take one graph away from this talk, it's this one. This is observational. It's two different periods. The blue dots show 1895 to 1980. This is a region that spans Texas to Louisiana, sort of south of 33 degrees north. So really the center of the heat wave. Precipitation, the precipitation deviation for climatology on the x-axis and the average temperature on the y-axis, and you can see a pronounced relationship. You also see that for the red dots, which are all the cases from 1981 to this year, you see that the entire sort of pattern, this sort of relationship has shifted upwards to warmer temperatures. So it's really about a degree or so Celsius warmer in the recent decades. For a given amount of precipitation, you're getting about a degree Celsius more average temperature for the summer. And you can see 2023 and 2011 being the champions here in warm temperatures. And again, the similar earlier years were probably a degree and a half lower in temperature. Just to show that climate models show this as well, this is just an indication of what you'd expect in blue for the probability distribution without the dots on it, just some contours shown here for 1951 to 1980 in blue, and an estimate of what you'd be expecting in this year by looking at a large ensemble of climate models. So we get a large number of samples for a given climate. So the physical relationships there in models, as well as this upward shift. And we're doing a little bit more statistics and on looking at other models, which show different amounts of shift, but show the same consistent pattern. And you know, this is to me a strong indication that this shift is really a result of climate change, but that the factor of the dryness is competing or perhaps larger as far as what led to the warm summer. So the key message, there was just to boil it all down, there was a widespread heat wave across the southern tier. Persistent anomalous ridge in the upper atmosphere led to low precipitation that played a key role in the persistent high temperatures. Recent dry summers have been about 1 degree to 2 Fahrenheit warmer, perhaps, than prior years, with similar precipitation deficit consistent with the effects of anthropogenic climate change. And the model projections indicate that there is a continued and increasing risk of such heat waves as the climate warms, especially in dry years. So this is what I came down to at the beginning, talking about conditional attribution. I'm not saying the extent to which that warm, wet period might persist, but it does say that when you do have dry years, and as you can see by this year, we still do have dry years, you will see these very high temperatures. And I'll leave it at that, and then go back to any sort of question and answer. I don't. Please let me know. Thank you.
Thank you, Joe. As a reminder, we'll have time for Q&A after all 3 presentations, but feel free to add your questions to the chat as you think of them. Our next presenter, Dave Dubea, will talk about fire conditions and outlook. Wade is a Louisiana State Forester and is the Louisiana State Forester and Assistant Commissioner of Forestry with the Louisiana Department of Agriculture and Forestry. Take it away, Joe.
All right. Thank y'all. It's not a problem. I've got a little bit of the highlights from the fire season, the Tiger Island fire, to share with you. And we've got some statistics pulled together. It was very interesting listening to Joe's presentation. I think when I share some of the stats that we pull together with fire numbers in Louisiana, it's going to overlay with that information very well. This was August 22nd of 2023, and this was the Tiger Island fire approaching Highway 26 over in southwest Louisiana. And we had some very unusual fire behavior as a result of the weather. And we'll see some of that play out in the numbers as we continue to go through the information here. We were dealing with fires in Louisiana that presented us with challenges because we were accustomed to going out, responding to a fire, working that fire, plowing that fire out, and either going on to the next fire or going back into a standby mode. And unfortunately, because of the conditions, we had to make adjustments to the way we were fighting fire over the summer. This was the first time in my tenure as state forester that we had to call on out-of-state resources to help us with the fire situation over the summer. Also the first time that we used the aerial support that became available to us. What you see here is one of the Louisiana National Guard helicopters with the Bambi buckets that were used. The way we had to work was in tandem with the aerial support. They would come in, provide us with the water to knock the crown fire back down, to cool it slightly so that we could get a dozer in behind and try to pinch the flanks on the head of that fire. We also utilized large air tankers, very large air tankers that were made available to us through the state of Texas agreement, and then eventually using the federal resources that came in, and a tanker base was established in central Louisiana, Alexandria, Louisiana. And there we were able to utilize the various aircraft that were available to us on the fires. In addition to Tiger Island, I think we used aerial support on probably 6 other fires. We had 4 fires that were considered major fires, FMAG type fires in Louisiana at the time. And the aftermath, the area where these fires took place was mostly timber, and it burned through. We were dealing with flame heights 200 to 300 feet was not uncommon to deal with in this situation, which is uncommon for us here in Louisiana. The fire behavior was such that when our crews got out to a fire, we were dealing with the situation where the fire, we would have to continue to redeploy in advance of that fire because of the rapid spread. And of course, this is a scene from near Maryville, Louisiana. It burned through. The Tiger Island fire burned. The final estimate, or the final acreage calculated, was 31,290 acres on that single fire. And we were fortunate that we were finally able to get, with the airdrops and whatnot, a change in the timber going to an area where the timber had been harvested. So the fire was forced to come back down to ground level so that we could deal with the 2-dimensional fire. And that over the course of several weeks of fighting the fire, we plowed this particular fire out. I think in conversation with some of our foresters out in the field. I think 4 times we got this fire to a point where it stopped, and then it flared up again, and began to move in a destructive manner once again. Yeah, and simultaneously we were fighting other fires. I've got a map that will come up shortly that shows you the location of all the fires we were fighting in a 3-month period, and it was very overwhelming for us. One of the issues that we dealt with was the weather that we count on here, or we're accustomed to. I shouldn't say we count on it. We're accustomed to in Louisiana is in a situation like this where we have 3-dimensional fires. We work with trying to control the direction of the fire and minimize the head of the fire. And typically what we see is at night, when we get the dew point and the moisture in the atmosphere increases, the fire will lay down and become a 2-dimensional fire. And we have that overnight period to work on suppressing that fire. Because of the temperatures, because of the drought conditions, because of the stress to the trees, because of the wind and other factors, we were not getting that overnight assistance from the weather that we typically had to rely on. And so we were constantly fighting 3-dimensional fires around the clock for several weeks. This is a photograph. This is Highway 26. And you're looking at basically center lane here, the over to with the improved shoulders and whatnot. The fire, that first picture I showed is the opposite side of the road. Fire jumped right across here and began to burn on the opposite side. And within a matter of seconds, we were chasing flames that became crown fires once again in a different direction. Most of the wind during that time was of an easterly direction, so south, east, and extremely variable. And so fighting fire on this side of the highway at one time, and it was not uncommon an hour later to be on the other side. The wind shifted 180 degrees, and we were fighting off in another direction. So these are the reports that we got throughout the event that were very helpful to us. It basically reinforced what we already knew, but it provided an overview of the fuels and the behavior in those areas. I think it's important to point out that the areas in Louisiana where we were dealing with these catastrophic fires, just a couple of years before, we had 2 major hurricanes go through the area, Hurricanes Laura and Delta. So we still had a tremendous amount of hurricane debris, blown down timber and so forth that was there to burn. In addition to the additional fuel there, it also provided a problem with the way we fight fire, in that we try to get in there with our dozers and plows. And because of the timber all over the ground, it posed a number of problems, from maneuvering and moving the debris around to the damage that it caused to the equipment that we were trying to get in and try to work to suppress these fires. Second page of this advisory, if you look at here, was the advisory area, and I think it overlays with the presentation that we just saw that showed the drought conditions across the lack of precipitation, and this was the previous advisories actually included Texas as well. This moved across Louisiana and into Mississippi and Alabama. These are some of the numbers, and I think if you look back, this will be an indication of what has taken place over time, and it supported the information that Joe just presented from the standpoint of if you go back and you look at the number of fires and the acres burned over time, we had a couple of years, or 3 years or so here in Louisiana, that we got a tremendous amount of rainfall. And so our fire numbers were well below average for us. You know, to have a fire season, a total number of fires for, you know, in this case, 2020 was 328 fires. Compared to what we are dealing with now and have been dealing with in the years just following that period, is just a very sharp contrast to what we have seen over time. And again, this shows you from 2019, the fires by month over that time. And if you look, there's a box highlighted in each of these tables that shows August, September, and October, which were the period of time that we were dealing with the major fires here in 2023. And just to look at a comparison of fires that occurred, you know, if you look at the fires in August of 2023, 555 fires, and, you know, go back to any of these, you know, 65 fires the year before, you know, 15 fires the year before that. We were coming out of that moist period of time, and we moved into the drier period and the drought conditions, and we saw the fire response to that adjusted accordingly. This graph shows those totals over time as in number of fires, and again, you can see here that during the years where we had the precipitation, the numbers were down, and coming out 2002, you know, 1,400 fires. And if you move over here, this was, you know, we're not through with 2023, so we're going to surpass this number easily as we go through this year. Note 2022, 2023, and let's move to the next slide. This is the number of acres burned. So even though we had a tremendous number of fires, they were relatively small. They were two-dimensional fires. We could respond to those fires, and we plowed them out quickly before they grew into any kind of large acreage that we were dealing with. Not the case in 2023. You know, we typically file in a given year, and I'm going by best memory, the 209 is a report that we file. For those of you that aren't familiar, 209 is a report we file on any fire that exceeds 100 acres. And I think in a given year, if we filed 7 or 8 209s, that was a high year for us. When we got into this year in August, most of the fires began with a 209. So, you know, we were hitting those 100-acre fire sizes very quickly. This shows August, September, and October for 2023 compared to those same months with a 5-year average. So if we average the number of fires for the last 5 years in August, you know, we're looking at 48. Just 2023, we had 555 fires, and accordingly with the other months. So you can see that the number of fires is tremendous. Again, we're going to see the acreage associated with that the same. The 5-year average for fires the entire year, we averaged about 445 acres burned, and this year alone, where we are now was, you know, 53,000 acres. This is a look at those 3 months for 2023 versus the same time frame back to 2013. And again, you see the trend here for the wetter years that we had compared to what we got when it started to dry out. And then again, I expect this number to grow over time. And we see the same trend here with the 3-month period here and number of acres burned. And even though 2022 was, again, a substantial year for number of fires, the acres were kept to a lot less over that time frame. Total number of fires for that time period, for the 3-month period that we saw so far this year, 938, and the 5-year average for those 3 months has typically been in the 100 to 200 fire range. Acres, again, accordingly, 1,400 acres is our average fires per year, and that's been very consistent as far back as I can remember. When someone asks me how many acres are burned, usually it's in the 12 to 1,500 acre range, and this year, of course, we're way past that. This is a map that I was talking about earlier. When you look at the number of fires, and please keep in mind down here at the bottom, all of these fires took place between August 1st and October 31st. So August, September, and October, we responded to over 900 wildfires in Louisiana in these areas. And again, if you look at the area where the majority of these fires took place, and particularly the largest of these fires, and those are identified right here. We had Hurricanes Laura and Delta go through here, and we had Hurricane Ida go through here. And so, those were where we had the largest amount of fuels on the ground, and also the areas where we did not get the quick response, if you will. We had so much damage to residential and commercial properties in these areas as well that there was a time lag. Landowners were worried about getting their houses repaired or rebuilt. And so therefore they just have begun to focus on trying to get the land cleared up and replanted. So that fuel remained on the ground for a number of reasons. And I think to add to that story, if you look at these fires here down in the south of New Orleans area, these are the fires that for the last week or two have been giving us the most problems to deal with. And that's because they're in the marsh area or the swamp areas of Louisiana. And what's happening is, because of the drought, these areas are dried up, and these fires are burning in the peat layer below the surface. In most cases, there are no visible flames. And so we're having to, once again, come up with new ways to try to fight these fires. We're not equipped to fight fires of this nature. We fight fires with bulldozers and, whatever we can in the forest. What we're doing here on this one particular fire, it's a 200-acre fire, and we're working in conjunction with the local fire departments, the U.S. Army Corps of Engineers. We got Forest Service representation and private entities out here, and we're actually flooding the area so that we're trying to extinguish this fire from below that peat layer up. And so we're pumping just thousands of gallons of water from the surrounding area into this contained area to try to extinguish that fire. So that was a quick overview, if you will, of what we've dealt with this summer with our wildfire situation over the state, and what we continue to deal with over time. There are a lot of other issues that are going on as a result of the drought in the areas. And I know you're going to have the presentation on what's going on with saltwater problems, with the Mississippi River problems and whatnot. Those are all contributing factors for us as well, because we rely on so much of that moisture into those areas. And it's not there. The stress to the trees has been tremendous. We're seeing a lot of dieback from drought conditions, and that creates another issue for us with needle cast and other concerns that are taking place in the pine areas. We've got hardwood areas that are burning now, where the areas that typically hold water year round are now dry. And so cypress swamps, we've responded to 3 cypress swamp fires in the last 2 weeks. So a lot of new ground for us in trying to learn how to handle these wildfires and to move forward. So that again is an overview of the fires, and I know we'll have some time for questions at the end of the presentations, and I'll be happy to try to address any of those for you at that time.
Thank you, Wade. And wow, your graphs and maps really drive home the severity of the 2023 fire season. One reminder again that if you have any questions, please type them in the questions box in GoToWebinar. Our final presenter, Jeff Graschel, will talk about Mississippi River conditions and outlook. Jeff is the Service Coordination Hydrologist at the Lower Mississippi River Forecast Center. His office provides river forecasts across the Lower Mississippi Valley and works closely with the U.S. Army Corps of Engineers and U.S. Geologic Survey. Go ahead, Jeff.
All right. Good morning to everyone. Hopefully you can hear me okay. Had some technical difficulties this morning, but hopefully things are working now for us. Are you able to see the screen okay?
We can see the slides.
How about now?
Yep, looks good. Thanks.
All right. Sorry for the technical difficulties here. It's been one of those days. I'm going to talk for a few minutes here and try to get there a little bit quick. I know we're getting close to the top of the hour about the Mississippi River conditions and outlook for our area here. So we got the low water on the Mississippi River. Obvious reasons are because of lack of rainfall that we had starting really back into the middle portions of May. And really, as we got into June, we had really large deficits of rainfall that occurred over the Midwest areas, especially the lower parts of the Missouri, middle portions of the Mississippi River. Not quite as much over the Ohio, but this is really what started our trend of going down and low water conditions that started very early in the season. So we were pretty concerned that we would really get into some really dire situations as we went into the summertime. We were fortunate enough, though, in the summer that we actually did get a little bit of rainfall that occurred over parts of the area that kind of helped us in keeping us from getting to the really record levels that unfortunately occurred later on in the season. So as we got into September, though, we had dry conditions over almost the entire basin. And that's what really led to having some of the record low levels that we had on the lower part of the Mississippi River. So this is a graph here that's kind of showing you the historical hydrograph or historical stages for Memphis, Tennessee. Blue is 1988. That's really what our modern day record lows for the lower part of the Mississippi River. And then the black color is actually 2022, where we had another low water event last year, a lot of it occurring into the September and October time period. And then the red line here, or maroon, is what we currently have for this year. So kind of you can see with this May, June time period, we really had a pretty good drop here. And then into June, we were really concerned that we were going to start reaching some of these record territories. And then we got those rainfall that occurred into July and parts of August that kept us, at low water, but not, to the record levels that we had that we had back closer into September and October. So you can see the lines here. We were exceeded some of the records that we had in 1988. And then as we got into October, we really got to the record low levels, that all-time record lows for the Memphis area. And luckily, though, we've had a little bit of rainfall that's kind of recovered that a little bit. The area here that I've got circled is really from the mouth of the junction of the Ohio and the Mississippi River southward to just above the junction of the Arkansas River. All these locations exceeded records. The records from 1988 and then records that we actually had from earlier in the year, and then also in 2022. So all these areas here produce record levels that from all-time record levels that we've never had, and these records can go back over 150 years in some of these locations. We've recovered quite a bit. We've had a number of rain events that have occurred over the Mississippi Valley and then a little bit over in the Ohio Valley. And so we actually have a pretty good rise that's working its way down the lower part of the Mississippi River at this time. Memphis is just now crested just about yesterday at -5. Our record that we had at that location earlier in the October period was -12. So we've risen about 7 feet on the river from the low water records that we had earlier in October. And so what we're seeing right now is that rise is continuing to work its way downstream towards the New Orleans area. And we looking at the hydrographs and looking at the rainfall, we're seeing that we're going to still maintain levels that are going to be higher than the records that we had earlier in October. This is a graph that uses 10 days of what we call the GFS ensemble. So it's 10 days of rainfall that we use all the different ensemble members to come up with what we're looking at out in the future. And we run this out through 28 days. And so what we're kind of seeing right now is that we're currently at that -5 foot level. And right now, at least the mean from all those ensembles are kind of keeping us around that level as we go into the early parts of December. So if this is right, we do anticipate that we're not going to see the record levels that we had back in October, and that red line is kind of indicating where those record levels would be on this graph. Another model that we have is our upstream office, River Forecast Center at the Ohio River Forecast Center. They're able to run a 43-day kind of a climate model and run through scenarios and ensembles to kind of give us an idea of what they're seeing out in the future as well. And that model is also trying to give us some good indications. This red line is kind of the mean of all those ensembles. And that's also giving us a good indication that as we go into November and then through the middle portions of December, that model is also showing indications that we should be rising here over the next several weeks to a month period of time. The winter rainfall outlook, seasonal precip outlook is right now pretty characteristics of an El Nino event where we're seeing above normal along the coastal sections, and then there are indications of below normal across the Great Lakes. Now, the area that we need the rainfall to really help us on the lower part of the Mississippi River has to occur really in the lower parts of the Missouri, the Mississippi, and the areas of the Tennessee and the Ohio Valley. Any rain that we get here in Louisiana really doesn't help us for the lower part of the Mississippi River. The reason why is it's very leveed along this area. There's no large tributaries that actually go into the Mississippi River as you get down closer into the parts of Arkansas, Mississippi, and Louisiana. So the rain that we need to be able to recover and help our low water conditions really have to happen well to the north of our area to really help us. Climatology wise, and just what we were seeing in our models, typically we do start to get frontal systems and rainfall systems that occur, especially as we get into November, December. And those trends with the mean monthly stats that we have here, and this is location is actually at Cairo, Illinois, where the Ohio and the Mississippi come together. But we typically get conditions where we start to see higher levels, more rainfall, runoff to allow us to get up to the levels that we get as we get into our peak flood season, which occurs in March and April. So some of the impacts, as probably people are well aware of and stuff, has been water supply issues below New Orleans. We typically do get a saltwater wedge that occurs just about every year, but in typically about every 10 to 12 years, we get a situation where the saltwater flow starts to work its way northward, and the Corps of Engineers has to construct what they call a seal or an underwater seal or a barrier to kind of block that saltwater from moving northward to help any of the communities below New Orleans to allow that saltwater to not get into their water supply. We had low water conditions starting into June, and so with that flow and stage information forecast that we had, the Corps went ahead and built an actual low water sill back in July. Well, about the middle of the September time period, the saltwater wedge actually started going over that sill that was constructed in July. And so the Corps had to re-raise that sill up another additional several feet to try to continue to block that saltwater barrier, saltwater wedge moving upstream. So that actually happened in October, and luckily that's actually been the thing that has stopped the saltwater from making its way northward. And it looks like it's going to be work well enough to be able to keep it from making its way up into the New Orleans area. So thankfully that additional foot of rise, several feet of rise that they did on the sill itself is actually helping with being able to keep the saltwater wedge from getting into some of those communities. The kind of neat thing about the saltwater wedge too is that it's constructed out of dredge material and stuff, and then once we get higher flows, it actually kind of just washes us away. So it's a kind of a neat thing where they can build this up. Low water conditions will keep it from, and then keep the saltwater from moving upstream. But then as we get higher flows later on the year, it just kind of washes away. So they don't have to deconstruct that sill that's on the lower part of the river. The other really big impacts that are going on are to the navigation community. Obviously we had a low water event in 2022, so a lot of the locations where they knew that they needed to do a lot of dredging in low areas, they were kind of already aware of those from 2022, so they were able to get in there pretty quickly in 2023 to start getting some of those areas that were the hardest hit from that last year event. So they were able to really dredge and help out quite a bit and be a little bit and be pretty proactive and be able to keep things open. But still, with the record levels and stuff, that's still causing a lot of problems for these areas. The biggest thing is that it's increased the travel time moving downstream about 40%. And the reason why is you just have less draft. You have a more confined navigable space on the river. So you can see like a barges and tows that you see here, as they're traversing through some of the areas that are pretty narrow, what they're having to do is they're having to take some of these barges off and then kind of fleet them and put them off to the side, get through a narrow area downstream and then park those, and then that tow has to go back up and then get those barges back and bring them back downstream and then put them all together to continue to move down. So that's caused a lot of reduction in the amount of time that it's taken for barges to be able to work their way upstream and downstream. So obviously those reductions really are a big economic impact for being able to move cargo upstream and downstream. No exact amount of economic impact values that I'm aware of right now, but certainly that'll be a pretty big thing, especially as the agricultural community is trying to get their harvest downstream and the fertilizers that are in our neck of the woods moving upstream for next year's crop season. So kind of in conclusion here and wrapping it up, the rainfall has really alleviated the low water conditions that we had earlier and record low water conditions. We're still got low water conditions that we're still dealing with. We're not seeing anything that gets us back to the record levels at this time. But if we were to get another stretch of a month to a month and a half of really no rainfall occurring in the upper parts of the basin, we could certainly get back down to the levels that we had early in October. We typically do, though, get enough rainfall in this as we approach the winter time to kind of alleviate some of the low water conditions. And we need about 300,000 CFS of what we call cubic feet per second flow out of the Mississippi River to really push that saltwater wedge back and allow us to be able to get out of the low water conditions. Right now, we're currently at about 180,000 cubic feet per second. That's roughly, if you want to think about that, that's about 700,000 basketballs going by in 1 second. That's the amount of flow that's in the river right now. So to be able to alleviate that saltwater wedge, we need about 2.8 million basketballs a second to get by our locations to be able to help us out. So with that, I think that is all I had, and I will turn it back over to the panelists and stuff.
Great, thank you, Jeff. Reminder, if you have any questions, please type them in the questions box and go to webinar. I know we're at the top of the hour, so some folks may have to drop off, but we'll continue to do our Q&A, and all of this will be available on the recording of the webinar that will be available afterwards. A question in the box for Joe. How will we know if when the Southern Plains reaches a tipping point where droughts are temperature driven rather than precipitation deficit driven?
Precipitation will always be a factor in drought in this region. Particularly, the Southern Plains really spans quite a lot of different climatological regions, from an arid west to a humid east, and the answer is different in the different parts of that. Let me put it that way. We already have temperature as a really important factor in the drier areas, but as you get more evapotranspiration from warmer temperatures, it sort of shifts that arid boundary a bit towards the east. Sorry about that. I'm getting a phone call there. That's really all I could say on that, because without doing a lot more in-depth research on that. But yes, precipitation will always be a major factor in this. It's just going to make the difference between a normal year and a drought year shift more toward. There'll be more drought years because of the greater evapotranspiration. Let me put it that way. I don't really want to commit to anything more than that, because I think there's others who probably could speak a little bit more to that than I could. Okay.
Great. Yeah. Thanks, Joe. Next question is for Wade. Can you talk about expectations or forecasts for the 2024 fire season? Wait, I don't know if you're there or not. If
Okay, now got it. Thank you. Yes, we're actually preparing for a similar situation. What we've been able to take away from this year's fires, we've gone back and we've looked at what led up to as far as indicators, so that we will be watching a little closer as we get into that time as far as rainfall, drought conditions, and so forth. But we've still got quite a bit of the area, the hurricane affected areas that were not part of the devastating fires that we saw. So we are hopeful that we will have a little different situation, but by the same time, we are preparing so that we'll be in a better position to respond if we do get a fire season next summer that is similar.
Thanks, Wade. A couple follow-up questions for you while you're unmuted. Question is, I'm wondering if there are any loss of life and how many structures were lost in this fire, and maybe you can touch on any tree mortality statistics you can share.
Sure. To the loss of life, we were very, very fortunate in that there were no lives lost that were connected directly to the wildfires. There were a couple of deaths that occurred, but they were handled by the fire department, and they were part of fires that took place structurally and in that surrounding area, not related to the wildfire. So we're very blessed in that case. As far as residences lost, unfortunately, yes, there were a number of residences that were destroyed, or I should say structures, because in addition to primary residences, we had barns and other buildings that were in the path of these fires. The number of residences, I would have to go back and check to verify but I know we were looking at in the neighborhood of 20, 25 primary residences that were destroyed by these major fires. And I'm sorry, what was the third?
Any information you can share about tree mortality in the areas that were burned? Just an overall thought.
Sure. What we're seeing is that the mortality rates from fire has been tremendous. We are looking at the entirety of that acreage, some 54,000 acres, I believe that will be affected, that we'll probably have to go back in and do some type of restoration work in to prepare it to be replanted. What we're also seeing and we're monitoring right now is the secondary situations that cause mortality in the forest, and that is the trees that didn't actually get burned up and die were stressed so badly that we're seeing imps and graver beetles and other insects and pests that are coming in and preying on these stressed trees. So we have been responding to a lot of forest health calls related to that. So I think the overall mortality numbers are going to grow, and we won't have a good handle on that until after probably the spring, when we start to do our regular southern pine beetle trapping programs and whatnot. We'll get a handle on that. But yes, widespread mortality in these trees. Again, we had what we call dirty burns on most of them. It didn't burn completely from one point to the other. It burned around pockets, but the trees left in those pockets are the ones that are now showing the signs of the fire and will likely be lost as a result as well.
Wow. Okay. Thanks, Wade. One more question while I have you. It says, this summer, Louisiana was unusually hot and dry. How did the wind compare this summer with previous years?
The wind was not our friend. What we had with this, I mentioned earlier the wind direction, easterly winds. It's one thing that we learned: you don't burn in an east wind because it's variable, and you set the fire on one side of the line and you're going to be dealing with it on the other. Well, it seemed like the wind was predominantly southeast or east throughout all of these. More importantly, we had the gust of winds that came through, and to complicate the situation, any front that we had that brought any kind of precipitation, any kind of moisture to the area, typically came from southeast and moved across the state, moving in a northwesterly direction. And so what we got, the overall situation was the rainfall got dumped on the Florida parishes. What we got, it wasn't much, but what we got fell there. And by the time anything crossed over to the west side of the Mississippi River, there was no more moisture moving, or very little moisture moving that direction. But in front of the rainfall, in front of the part of that system that dropped the rain, we saw the humidity drop, and we saw the winds pick up, and we had lightning. And so that became our concern. Probably mid-September was, there's a front coming, get ready, because we got a lot of downdrafts. So anything that had been burning that we had contained, we had a line around it. It was still burning inside the lines. The wind caused the embers to flare up, jump across our lines, and we were fighting fire again. Or we had lightning, and once the lightning hit, the wind took it, and it turned into one of those major acreage fires that I talked about a little earlier.
Thanks, Jeff. Yeah, you got a really tough situation down there. Best of luck moving forward.
Thanks.
Last question is for Jeff. How did the rate of decline of the Mississippi levels in September compare with most years? Was that unusual?
Yeah, that's pretty unusual and stuff. Usually it's just a gradual fall. But yeah, it would, certainly you saw some of the graphics that we see that we, get into May time period or so. When you start that, the rainfall kind of shuts down a little bit. We transition to the summertime climate. you start to see a pretty good fall and pretty significant falls during that time period. But yeah, you don't usually see a pretty rapid fall in the periods of the September time period, October. It's very gradual. And so what we had this year, because of that, really not having rainfall over that month of September and really into the middle portions of August, that really generated a precipitous fall that you typically don't see on the lower part of the river for the fall time.
Great, thanks, Jeff. Those were all the questions I see. I'd like to thank all of our speakers today. Y'all did a really great job, and appreciate everyone who attended and sticking around a little bit longer. As I said before, this webinar has been recorded. It'll be available on the NOAA site after the webinar. Thanks, everyone. Have a great day.